So what we're going to do now is we're going to take a look at an example problem that perhaps an engineer would be faced with, where they would want to apply some of the concepts of mechanical engineering, thermodynamics. So what we're going to do is take a look at an example. So what we're going to do is consider a typical example or problem that an engineer would need to use thermodynamics in order to solve. So the problem statement that we're going to look at is to design a more efficient wood-burning fireplace. So that is our problem statement. So let's take a look at that. And what we're going to do, we're going to start by looking at a conventional fireplace and examining what is going on. So if you look at a conventional fireplace, so what we have is usually some form of enclosure, quite often made out of brick. And we might have a window in there on the front. But essentially everything ends by going up the chimney. In here we have an area where we can put our logs. So we have our logs sitting there. And then what happens, we have fire. So there are flames, a chemical reaction, and eventually what happens is the gases cool down and they go up through the chimney. So here what we can write is we have a mass flow rate of the products of combustion. So that's where the products of combustion are going. And as that's going, we need air. Remember, fire needs the components to have heat, air, and fuel. And so in this case, fuel would be our logs that are burning. And air would be supplied by the outer surroundings, so air is coming in. And then heat, you would have an ignition source. So in the process of that, a couple of things are happening. First of all, we have radiation energy coming out. So if you've taken a course in heat transfer, you will know what radiation is. That's the heat that you don't necessarily, it could be transferred through a vacuum, but you'll feel the heat on your face and on your hands as you get close to it. And we also have convective heat transfer. So that would be heat transfer through the gases, air, that is in near vicinity to the fireplace itself. And with the convection, you'll have both natural and perhaps forced if there's a fan blowing or something like that. So anyways, that is the process that is going on. Now, unfortunately, one thing that is happening here is along with the exhaust gases, we're also losing something else. We're losing money in the form of heat, because a lot of that heat is going up through the chimney and we're not recovering it. So we can make a comment here saying that most of the energy is lost in the exhaust gases. Now, as engineers, that does not make us happy because we do not like inefficiencies. So what we're going to do, we're going to take a look at the standard fireplace and see, is there a way that we can make it better? So let's take a look at that now.